All right, so I'm going to talk about how I added Ruby support to AWS Lambda, and the title of this presentation is called Jets, a Ruby-less Serverless Framework on AWS Lambda. All right, so now I'm going to do my intro, I guess. My background, the traditional background slide, is my name is Tung. I run a consultancy company called BoltOps. It's focused specifically on AWS and only AWS right now. Over the last couple of years, I've been very lucky to have written a couple of open source tools. So you see a bunch of logos up there. They're all actually AWS specific tools, and they are all actually focused in different areas of AWS. For my work in the Docker ECS space, I was recently recognized as AWS Container Hero. So that was cool. And tonight, though, we're going to talk about the one icon in the cloud, the two Jets binary, called Jets, the Ruby Serverless Framework. Okay, so I wanted to start the presentation off with this. I thought this was hilarious. This is a website called serverless-ruby.org. It's a petition. Basically, there's a bunch of people, and this guy started a petition in March 2018, begging for AWS Lambda to have Ruby support, and it's not happening. So, rumors are, there's a lot of rumors that AWS is actually working on its support, and it's just a matter of time, so hopefully when they add it, that'd be fantastic, that'd be great. But I just thought that this site was pretty hilarious. So, you can actually run Ruby on AWS Lambda right now, or any language for that matter. And a lot of people have actually documented how to run Ruby on AWS Lambda. So this road that I'm going to talk about tonight is a well-traveled road. A lot of people have actually done this. That first link up there is on the AWS Compute blog itself. That's Amazon's official blog. They've documented exactly how to do it in other languages, such as PHP and Go. That article was written in 2016, December, before Go support was officially added. Go does now run on AWS Lambda. Other guys, this one dude wrote building Ruby bots on AWS Lambda. Another guy wrote Romda, and I guess he takes traveling Ruby. A lot of people use traveling Ruby to bundle up Ruby, and then kind of add support to AWS Lambda that way. And another person wrote how to run Ruby scripts on AWS Lambda with Ansible. So a lot of people have done this before. And the way they do it, and they cheat it, is something called a shim. Typically a node shim. So what's a shim? So this is the trick. You write AWS Lambda functions in a language that's already natively supported, then you call out to another language. And then you take the results of, in this case, Ruby. Then you take the results of Ruby and you shove it back up to some natively supported language back to AWS Lambda. So that's actually how it's done with a shim. It's kind of like a moving exception. So I just found this random poster image online. It's kind of like a dream within a dream. So in this case, it's a language within language. And the issue with kind of accepting a dream in dream is once you kind of, let's see if this kind of clicks. Once you get into one dream, right, the first dream is slower. So it's kind of like the problem with shim are two sales, right? It's slow. There's some overhead associated with taking one language, call it to another language, and shove it back to another language, right? And the reason it's slow is because of something in AWS Lambda called the AWS cold starts. So this is a really well-known issue with AWS cold start. So that's supposed to be an image of a car cover snow, and the engine next to it show like a code engine to help me explain this. So, and AWS Lambda cold starts, what are they? So when you call an AWS Lambda function, essentially what happens is a container spins up. Your code gets executed, and goes to the results, then it's back back out to AWS Lambda. Well, there's some overhead in the very first time called that container because it never existed before. Alright, so that overhead is known as the cold start. And the really interesting thing about AWS Lambda cold start is it varies depending on how you configure the function. So, for example, let's say with the AWS Lambda function, you can trigger anywhere from 120 megabytes of RAM to 3 gigabytes of RAM. Well, AWS Lambda allocates a proportional amount of CPU according to the RAM you allocate. So if you're being like kind of cheap, which is fine, it's good to save money, but if you're only allocating 120 megabytes of RAM, you're going to get a slow CPU, like slow. So when you're allocating a little amounts of RAM, the cold start is even more significant, even up to a couple seconds before your Lambda function runs and executes. Let's say you're using a language like Java. Love Java, great language, but the JVM is kind of large, right? Loading that up out of this into memory Takes some time. It's just that's just how it can work. So cold starts are a problem in Java in the AWS Lambda world. Let's say you're using a custom VPC. So you want your Lambda function to have access to only your custom network. Well, what happens during the bootstrapping process of AWS Lambda is it selects an EC2 instance, then creates an ENI or version network card, then it attaches that version network card to the instance, then it does some magic to connect that ENI to the container, then it runs a function, and then it spits back up. So that's like a multi-step process. There's some overhead associated with that, upwards of over 10 seconds with VPC. So this is something you should be aware of when you're using AWS Lambda. But AWS Lambda developers know about this problem. It's a well-known problem. So what do they do? That is not an engine on fire. That's warming up an engine. That's what it's supposed to represent. That's what I could do? No, I did a little bit better in this next slide. So this is the pattern that a lot of people use when they operate serverless in AWS Lambda often. What they do is they set up a CloudWatch event rule on a scheduled basis. It periodically pings a Lambda function that then fans out and calls other Lambda functions within your application with a dummy pre-warm payload. The only point of this basically Lambda function call is to warm up your Lambda function. And so this is what you do. This is how you kind of keep your Lambdas warm, and then you don't have to deal with the cold start problem. Now, let's see what happened there. Oops, I think, okay, so the reason the Lambda pre-warming works is because of something called the Lambda execution context. So I explained what pre-warming was. So Lambda execution context, what is the Lambda execution context? Well, it's basically essentially the environment that Lambda function runs in is a reuse. So anything you put outside the handler code of your code block, that only gets run once, and that's the Lambda execution context. The reason that what matters is because once you understand that the Lambda execution context is reused, right, you don't have to pay that penalty. By using the Lambda execution context, you avoid the cold start problem. That's actually text from the documentation itself. Talking about the cold start problem, talking about the Lambda execution. That's AWS documentation right there. And so the reason I gave you all this context, why pre-warming, Lambda function is important, what the Lambda execution context is to understand how you add native support, not just to Ruby of any language, it is Lambda right now today at native speed. So what Jets does is it takes the Ruby interpreter, it shoves it into Lambda execution memory and keeps it in there, right? So subsequent requests are extremely fast, basically native speed. And here is a quick performance benchmark. So above there, you have Ruby function you curl out to. That's returning 164 milliseconds. The bottom one is Python, 178 milliseconds. They're essentially the same, right? It doesn't really matter. This bottleneck is not going to be the Lambda function, it's going to be the network speed, right? Okay, so quick demo, very quick. So let me switch over. I think I'm actually going to log in, so this is going to be fun. Oh, sweet, I'm in already. But I'm going to just one test. All right, so this is going to be fun. I'm going to try to tap one-handed, see how this works. Okay, so this is a curl request of a Jet application already deployed that's hitting a Ruby function. You can see it's returning about 200 milliseconds. And here is another curl endpoint that I'm hitting right now that happens to have Python. That's the cold start right there. Okay, Python's not actually being pre-warmed. But you can see it essentially is the same speed. So I just want to show you that live real time. Okay, so back to this slide deck. So we did the first demo. So before moving on, I wanted to go why again. Why? What's the point when you're doing this, right? If you're going to be working a lot with AWS Lambda, you're going to eventually be working with something called cloud formation. Cloud formation is infrastructure as code. It's the way basically write your Lambda functions up and YML, right? But this kind of reminds me of the 1990s when Java was moving a lot of their kind of logic from Java code, which is fine, to XML. And it was always like debugging XML, you just have to change that slight little thing, then it will start working, right? Because you're not actually writing code, you're writing YML or you're writing XML, right? So that function up there doesn't actually look that half bad. It's like 15 lines of code. It's pretty understandable. But imagine you have an application with 20 Lambda functions, okay? And then you need it to test memory size. You got to copy and paste 20 times and run, right? So on the other side there, you just basically have Ruby, which is being used as loop code to generate basically that exact same yarn. But now you have access to the power of programming language, which is going to make the code way more maintainable, way more real. Okay, so this is a typical web architecture that's serverless. There are no servers here. This can be built with Jets and or other frameworks for that matter. What we have is you have a user request coming in, it's hitting the API gateway, that's a RESTful API. Those endpoints then call Lambda functions and they can return. So we're going to actually do a demo of building this entire thing during this presentation. So I'm going to actually show you, I'm going to show you some code first. So we talked about like AWS Lambda now, pre-warming, the Lambda execution context, hopefully that was helpful. But actually I'm going to show you the code here, like AWS Lambda code. So AWS Lambda code, usually all you do is define a method and node. And then you take in an event and context, and node plan looks the same, and also Python looks the same. This is just written in Ruby form. This is what it would look like if AWS Lambda was supporting it, right? But the funny thing is, there's actually not a lot of value with this besides adding Ruby support. There's not a lot that's doing there, all right? So Jet's code actually looks more like this, right? This is inspired from Rails. That's a controller code, inherits from an application controller, right? And if you're creating a post controller, there's two actions there. There's init action, there's show action. So there are two Ruby methods there. You have access to a render helper. That render helper render JSON, render HTML through action. You also have access to parameters. You have access to the raw Lambda event itself, the raw payload. All right. But even though that looks like there's a couple of Rails programmers here, even though that looks like Rails code, that is not. That actually generates Lambda functions for each public method out there. So what Jets does is basically it evaluates the code and it generates Lambda functions that correspond to those methods that are public methods. So those are the primary corresponding Lambda functions over there. They're the corresponding Ruby code. Jets also supports routes. Once again, it looks like Rails routes, right? You draw the routes and you say, connect this URL to this Lambda function or this controller action, right? And what that actually does is it generates API gateway resources. So those lines of code right there will generate all those API gateway resources for you. Jets also has a notion called jobs. So this is nothing more than back jobs, pretty popular pattern. You don't really want to block out web requests. Any request that takes longer than a second, users are going to leave. So you got to keep that web request fast. So the common pattern is throw any slow code into a background job or a queue. So Jets supports that also. So you have kind of the rate kind of expression up there. So it's going to run that basically method every single 10 hours. And there you have cron, that's going to run that method every single 12 hours. But once again, that creates AWS resources. That's creating AWS event pool. So AWS has something called AWS events, and there's actually something called schedule events. So you don't have access to a scheduler. You don't have to run a separate scheduler here. You don't have to run a separate worker tier because that's running serverless. The scheduler tier is also serverless. Okay, so this is what a typical Jets project structure kind of looks like. You have the app controllers, the helpers, the jobs, the models, the views, the typical MVC. The JavaScript loader is using Webpack as what Rails 5 is currently using right now to package up JavaScript and CSS. There's a bin folder, there's a config folder for database YML and other application-wide settings. DB folder for migrations, both DB as well as basic active record, Postgres supporting. The public folder for serving public assets, and the spec folder for tests. Okay, down number 2. You guys get 2.
It's okay, Paul?
Yeah, I think I'm fine. And you guys can hear me too, right? So I don't have to pick up the mic? Okay, good. All right. So, CD, let me make sure I'm on master, because I was messing around with this in the hotel. So Jet's new demo, okay? So for this, what I'm gonna do, okay, actually, I can actually talk over here. Okay, so the first command is Jet's new demo, right? So what that does is that creates basically a skeleton app with all the folders that you kind of need: app, controllers, views, config, public, all that, right? And then immediately it does a bundle of stuff. So it installs application dependencies. Then it installs Webpacker. Oh, I guess the command finished. So then it installs Webpacker. So that's what doing Webpacker is a lot of outputs. I'm just going to skip right through it. And then it does get initialized and it does your first commit. All right, just from one command, and then it gives you a congratulatory message saying, okay, this is what you need to do next. Okay, so we're going to do what it tells us, I guess. Okay, so I'm going to see into demo now. I'm actually typing go ahead because I use copy and paste here, that makes it easy. Then we run scaffold. It's kind of familiar, isn't it? So that created a post model with a title column with a migration to. I don't have to migrate because I've actually migrated this database locally already. Now I'm going to start up a local server. So I'm going to bind this local server to 0000 because this is actually a server running on EC2 under another service called Cloud9, which is the browser. Right? I'm using a browser right now as my editor. It's basically a remote editor. Okay, so let's actually go check this out and see what happened. Once I figure out my Chrome numbers here. Okay, so I already set this up. Live demo. So I'm going ahead and hit this. So I started a server locally, and by default it runs port 8080, and that's a slash local page. So that's the app I'm running right. And remember, I created scaffold with post, right? So let's check out post. Oops, purely slash. Okay, so here's post. Loading, eventually. Okay, there we go. So you got some records ready. I already have a database. Let's create one more record just to show you, so you have like the basic front is working from the back with that scaffold command. So post 5 submit. Okay, we'll go back. You can see, so the front is going to work locally. So what we're going to do now is we're going to take the application, we're going to pull the AWS Lambda. Okay, Control C, kill the server. Then I'm going to run the next command. So the first thing I'm doing is I'm copying environmental variables, which sets up the database underscore URL. Because actually I have to point a remote database, right? And this is going to be running AWS Lambda. So my database credentials are in there. And then I'm going to run the just deploy command and explain what it's kind of doing, I guess. Yeah, I'm going to hide this.
Is that running locally or on the cloud?
This is, you can think about it as locally, basically. But basically I'm using Cloud9, which is a IDE that's browser-based. Yes, but it's essentially locally, right?
Okay.
So the reason why I'm actually using Cloud9 is, I'll explain this is, so what Just Deploy does is first it bundles up your assets locally in a temporary area, because it needs to figure out what Gens needs to zip up into the code file and uploads S3 for AWS to run. So it can bundle all the dependencies locally. And on top of that, then also sets up a vendor copy of Ruby, right? AWS Lambda is for Ruby. So what it's doing here is it's literally shoving Ruby, the interpreter, into that AWS Lambda. You can see it's actually pretty big, 76 megs, right? The limit is 256, or 250, I believe. So we're still a little bit far from the limit, so that's good. And then it also does some evaluation of the gems to see whether or not the gems have compiled extensions, and they do, then we replace with pre-compiled gems that are working on within the AWS Lambda environment. Okay, and then it finally does a confirmation stack update, which basically handles deployment. So you kind of see the point. You can also see right here time to upload code. This is why I've switched over to Cloud9. It takes a while on my slow internet connection home to upload 76 minutes. That uploads in 1 second because thanks to AWS generous EC2 download. Right? So what's happening right now is actually deploying the app by confirmation. So why don't we go jump and take a look at confirmation to see actually what's going on. Okay. Confirmation. Oops. I am in the wrong account. Great. That's one of my clients. So let's log out. Okay. So let me log in. Just a second. Okay, just a second, I gotta switch over to the demo account. Okay, so I'm logged into the right account. Anyway, so let's go to confirmation, and so let's take a look. Okay, there we go, update in progress. So it's still kind of creating resources, but you can see the confirmation stack that Jets basically deployed. So Jets basically deploys along these AWS resources via confirmation. You can see there's more than one confirmation template there. There's a couple of confirmation templates that are nested. This is to get around the 200 resource limit of confirmation. So basically, nested stacks you get around limits, and you could have as many resources as you need. All right. So what does actually confirmation create? Right now, we're going to start taking a look. Let's look at the demo now. App, controllers, hosts. All right, so we're going to actually look at the code now. All right. Let's also bring up routes up to the next team now. Let's kind of move it down here. Like that. Like that. And just one second. I did that pretty good with one hand. Okay, anyway, so let's look at Lambda. It's still deploying, but it should, let's see where the deployment is right now real quick. So yeah, the deployment's actually completed now, and then it spits out the API endpoint, so you know where the application is. So you can actually grab it and go test it. So why don't I actually really do that real quickly right now? Let's grab this endpoint. Okay, and there's the Jets app running, this time on AWS Lambda remotely. Okay, so let's go to scaffolding, hosts. Okay, there's a scaffold, and let me click around and kind of create some records, I guess. Those 6, submit. Notice as I kind of click around here, how fast this is happening. This is basically essentially native speed, because it's keeping that Ruby interpret in memory in that Lambda execution context that I explained earlier. Okay, so there it is. It's the front app up and running there. Okay, let's see. Let's actually look at the resources so we can understand what's going on here. Okay, so there are the Lambda functions on your left, and there are that's like the devs code on your left. Now I can still this because the whole devs app's running, you know. Demo, and here are the Lambda functions, the corresponding Lambda functions here, right? There's separate Lambda functions right there. And why don't we just go in and actually run Lambda function on the console, right? Just so we can understand what's going on here. So it needs to test tables. If this action doesn't actually use the parameters passed in, so you can run anything there and say test. And you can see returning about 15 milliseconds there, and it returned a JSON payload. This JSON payload is called a Lambda proxy structure. This is kind of the structure that API gateway expects from a Lambda function in order to parse out and then serve a HTML page. They expect the status field, the headers, and the body. Okay, so that's the Lambda functions. Let's see what else we should check out. API gateway. And the route style down there, right? So that one resources line extends out to the 7 product resources, right? Create, read, update, delete, and then here it is. Here's demo dev. And those are very corresponding to what the resources right there. Okay. So let's see. I think I'm gonna go back to slide deck. Okay. So 2 demos that's done, and I just want to review what we just created. Right? We created a completely serverless architecture on AWS Lambda with a couple lines of code and a couple of commands. Right? We created all the API gateway specified ones there. We created all the Lambda functions to connect to the RDS database that I did create. Right? We did not create down there the scheduled jobs just for the sake of time. Okie dokie. So I want to Jet support resource model. I'll talk really about this. So the code on the left is a hard job, it's a background job, and it's a rate method that tells it run this Lambda function every single 10 hours. Right? I just want to emphasize that that one line of code expands out to a resource method and call that resource method. And that resource method then associates a how watch event rule with the Lambda function right there. Okay? So the reason why I'm pointing out is this is a core model within Jets. Every single kind of convenience method like rate or cron leads to the resource method. All the apps in Jets leads to resource. By understanding this, you can actually create any custom resource you want on AWS. And And then you can create your own wrapper on top of this, make it more convenient, more pretty, more maintainable. Okay? Okay, so we covered the API RESTful kind of architecture, but I've actually been building with Jets different architectures out there too. So this is event-driven security with auto remediation. So in this kind of diagram, what you have is a CloudWatch event rule pattern over there. And it's basically a modern CloudTrail for any time somebody authorizes or opens up support from a security group setting, revokes the security group, or creates a security group, or at least deletes a security group. And then what happens is watching that, and it will then fire off a Lambda function, and that Lambda function will be like, why do you open up port 22 to the world, close it back down, and send me an SMS alert, right? This is important for some companies with security concerns. And then what that Lambda function does is, regardless of security port, regardless of associated with EC2 instance, auto-scaling group or RDS instance down there, it will lock it back down within a minute, right? With AWS, things change so dynamically that you have to automate everything in order to keep everything secure. That's how you do it. That's the successful way of approaching. So what does that code look like? It looks like this. Security job. Event pattern, right there, right above the method. Then the method down there with the basics logic, custom to whatever you guys need. Then you guys get close back down on that security port you need to. What does that get translated to? This. YML again, right? So it's kind of insane. What we're doing right now, currently in Serverless, is we're writing YML and we're maintaining YML, right? And that's fine, right? It just, it's a lot of lines of code. And notice also that it doesn't just create a event rule. When you write the YML, you also have to create a permission. You actually have to give permissions for the Lambda function to be able to execute from CloudWatch event rules. But that's kind of handled for you with that syntax over there. Okay, so event-driven security also supports multiple event patterns. So let's say if you want to just look at multiple event patterns, you just simply declare more event patterns on top of that method. It appends it to array internally, and then it creates more AWS resources. All right, so I wanted to, before I cover the next architectural pattern, polymorphic support. So Jets is a Ruby serverless framework, but you don't have to write Ruby. Why? Why do anybody want to do this, right? Well, it turns out there's not a lot of Ruby AWS Lambda functions out there online. So if you want to reuse code, it's actually very beneficial to be able to write in another language, right? So Jets really acts as the glue between multiple languages and kind of glue all together. So this is kind of polymorphic support right now, because I found this actually very useful. You'll see some examples soon. But this is a Jets Lambda function running Python 3.6. This is also a Jets Lambda function running Node 8.10. And this is what actually polymorphic support looks like with Python. You see, the post controller has a Python keyword that references a symbol called index. And then you create a post loader, Python loader, language library there, and then you put in index.py as the right Python. Then you literally paste your Python code in there, and then move on to life, right? Node looks very similar. Node, this you call node keyword, you call show, you create a node loader, and you create your node loader there, so you can stick to the language of your choice. Notice though, with both Node and Python, the handler, you have to return the full Lambda proxy structure, the status code, the headers, the body. There's no extra help you're getting from Jets. With Jets, you don't have to do that, right? Or with Ruby code, that's kind of baked in. Because this is simple handler code. This is how most examples online for our reason. Okay, so another architectural pattern now that we've been introduced to polymorphic support is continuous compliant with AWS config rules. So AWS config rules is a service from AWS that basically constantly monitors your AWS account and ensures it's compliant according to your own business logic. So with AWS config rules, what you do is you pass a report, like a spreadsheet with a bunch of checkboxes, like green checkboxes, saying, look, I approved the security auditor that this account is compliant, right? I have proof of that too. And if somebody makes it uncompliant, I'll know within a minute, right? Continuous compliance. AWS config supports both managed config rules as well as custom config rules via Lambda functions, right? So they just released a bunch of new managed config rules, which is really sweet, so that we don't kind of write if we have to. But if you have to, then you write your own Lambda functions too. And what does AWS config rule look like? Hopefully you're starting to see a similar pattern, right? You can hear from, in that case, I guess that's rule based, but usually it's application rule. Then at the very top, actually, I define a property just saying every single function in this class is going to be writing on this Python 2.7, not Ruby, right? And then I give it a config description, a scope, because config rules are scopes of different resources. Config rule will monitor different AWS resources, and you tell it what resources to monitor with the scope property. And then there I'm using polymorphic support. I'm using Python to call out that pure Python method here that I did not write. Right? I just grabbed it. Just threw it in there and I moved on my way. And then this is kind of a dashboard, kind of a view of the fully compliant kind of account here that has been set up. Not fully compliant, but this is a bunch of rules that's been set up. So this is what actually AWS config the dashboard looks like. Compliant, show this your auger, kind of move on the way, right? And again, it's not going to happen with a cycle every single 3 or 6 months. It can happen every single minute. AWS just changes too fast. We have to do it continuously. Okay, I put together this just for this presentation because equally focused. They do the IoT things. Literally, I hacked this together 2 hours ago. Okay? Event-driven internet things. Okay? So IoT. You can like hook up anything nowadays to the internet, apparently. Because I had a lot of fun finding all those icons and throwing them to the slide. Alright? And then so these IoT devices, they can basically connect up to IoT topics, research that you create on AWS Lambda. Then you create an IoT rule which filters kind of which things you want to take action on. Then you do an IoT action and you call, guess what, the custom serverless Lambda function again. In this case, it's just an example, it's talking DynamoDB. So I literally hacked this together right before this. So what will it look like? One line of code, right? One line of code, the Lambda function right underneath it. That happens to be Ruby, it could be Python, it could be Node. Doesn't really matter. That's a temperature job, I guess, and it's going to report the temperature. And then you're going to set up the eventually DynamoDB. What does the code look like? And why not? This is what people are doing nowadays. Right? This is what people do. Alright, you can create Lambda function with this Java right here. Then you can create your IoT topic rule right here, reference the Lambda function, and don't forget, get the action permission or else it's not going to work. Right? There's the permission. And then you also have to make sure the principal is IoT, coming from the right service, because IoT is the service that's calling. Okay, so I wanted to kind of really briefly cover DevOps features. So we talked about pre-warming for like the first 10 minutes of this presentation. So pre-warming is baked in. Upon deployment, it calls pre-warming to pre-warm all your functions with that fan-out technique there. It also gets run on a regular schedule basis. You can configure it to higher schedules or lower schedules or faster rates or slower rates. Basically on the one configuration, top configuration application already. Local server, we actually use them now, right? It's very useful to be able to test their Lambda functions locally. Amazingly, a lot of people don't have this, right? Jet's call is another feature. So Jet's call, what that is a CLI command that also allows you to test both locally and remotely the Lambda function. You just have // local to test it locally. You can basically test your code before you deploy it, all right? There's a rebel console too. This is IRB, basically loading the Jet's environment as well as your application code. Another useful thing to test locally. Database support supports RDS Postgres currently and DynamoDB. Lambda function properties. So Lambda function properties, when you define a Lambda function or you update or edit a Lambda function, you can define like memory, timeout, custom VPC, you can define environment variables. All these things are Lambda properties. Just allows you to define function properties at the function level, so very specific to every individual function. You have separate function properties at the class level and also application wide. Right? So a lot of control over function properties. Very important are IMA policies. IMA policies basically control permissions and allows your Lambda functions access to AWS resources, so this is pretty crucial. IMA policies also give you control at the function level, at the class level, and application wide. And lastly, polymorphic support, which I kind of covered earlier. We can call other languages needed. Here are some working examples. I had a bunch more, but I just didn't get it in time for this presentation. But I'll eventually post them, and so there's a bunch more examples. For the guys who are taking pictures, there's a link to the slide down here, so you guys have it. And Q&A at the end here.
Wow, thank you.
Yes, question back.
I still, the runtime part is still Node.js, right? But how did you stick the Ruby in? Is the Ruby interpreter stuff written in Node.js or?
No. The question was, the runtime is Ruby, so how did I get Ruby packaged into Lambda? So when we ran just deploy, that's when it downloaded Ruby from kind of the S3 bucket that our 7.3 CDN. And that's a pre-compiled version of Ruby running on the pre-compiled it on an EC2 instance that was running Lambda AMI. So I used the official Lambda AMI, pre-compiled Ruby map, then now we talk the binary, right? As long as that Ruby is a compiled right architecture, it's going to run, right? And this is really interesting because a lot of languages have this problem too. Let's say you're using Node, which is officially supported, but you're installing Node and you're installing npm package. So that npm package requires a binary extension. If you compile it in your local machine and you package it up to the AWS Lambda, your code not going to work.
So are you running it in the EC2 resources outside?
No, it's all Lambda runs within AWS Lambda.
The Ember runs yeah, I understand. So you're running it right on the host itself?
Yes, within AWS Lambda. So I just kind of did it with the code, that's why it is, essentially.
Just running.
Yes, question.
You talk about keeping the functions warm, right? But who will be paying for idle then?
Sure. So that's a great question. So you said, I talked about keeping the functions warm, but don't you have to pay for that? Yes, you do. But if you don't do that, you're going to have a close start problem. So everybody does it. You have to do it. And usually Lambda functions, AWS is not very specific about how long they keep the functions up for before they start recycling them. But people have basically done a lot of statistics around this. It's usually a couple hours, like 48 usually. So I think by default, I have it warming every single 30 seconds. But yeah, you could adjust that. It depends. AWS is not going to be specific on that right now, at least. More questions? Okay, yes?
I'd like to know the performance data in two dimensions. One dimension we compare to runtimes from a serverless web platform and to the container web platform for machine. On the other dimension, do you have any data compared to people environment application into working machine, the same specific facility is the working machine that built by containers? Do you have data?
So the question was, do I have data on comparing
Performance data.
performance data comparing what, two different platforms?
Three scenarios. One scenario will deploy into a working machine.
Work machine.
Virtual machine, which is virtual machine, yeah.
Virtual machine, yeah.
So the second scenario will deploy it into a container using the same specific of the working machine.
Oh, I see.
And difference of performance data, and also comparing to the serverless instance.
Once the container warm up, there should be no substantial performance difference, right? But the cold start there will be, because the container hasn't started before. But once it's warmed up, no, the performance, the bottlenecks to the network speed, right? It's always going to be the network speed at that point. It's not going to be the container that's already around. It's already around. It's kind of like, and this is actually why, let's say you're just running a typical VM and a typical web server like Apache. You know, there are configurations of Apache that basically start with Apache and load your code into Apache memory before it starts running traffic. That's why they do that. Right? Apache doesn't have a close start problem because what you do is you start Apache first, you warm up your application, and then you start serving load balance traffic too. So,
How do you have the secrets and using the
sure, so secrets are right now handled through environment variables. So I'm going to add those on better secret support using Amazon's AWS Secrets Manager revenue service. And that's a nice stuff. So the question is how to handle Secrets Manager. Right now I'm just handling the requirements and variables, which will show up in Amazon unfortunately. But you can basically specify some environment variables for secret and then lock it down with what's called a KNC. That's just something that just needs to be added. Should be pretty simple. Yes.
One thing is clear to me, so are you still using a shell? So you still
So what's the original languages executing this?
Sure. So the question was, am I still using Shim? Yes, I do have to use Shim because Ruby story is an official story. And the original language that Shim written is Node.js. Node.js is the original.
So every request you spin a process from
Yes, but that Shim happens outside a handler code in the Lambda execution context. So that Shim happens once. Does that make sense? That's how you make tasks. That's the Lambda execution context.
The Ruby process is running, like waiting for time. You don't have to start for it.
Okay, I'm going to go back to an example right here real quick. Let's see, I just need to find one code example that has it. Okay, so right, this code example explained. So the Lambda function that's going to be running this code inside here is run not within the execute context. The context is outside of it. So the shape of Ruby outside here. That gets only run once. So if like, let's say you run this Lambda function and you go like push hello world, then you run it on the console not one time but 2 times, you only see put hello world 1 time. Because it's going to reuse this section and it's never going to run that code outside here at the same time. This is where the AWS Lambda documentation encourages you to establish database connections and make network calls, anything that's extensive, because it only gets happened once and gets reused. And that's the trick basically. You just have to see how AWS Lambda kind of works. Any additional questions? We're good?
Don't be intimidated by these complications. You'll ask any questions.
Yeah, sure.
Have you ever had a problem with concurrency? So if you have people starting a whole bunch of stuff in parallel, now you're going to have another one start because one that's having more is in use already.
Yeah, so the question was, have I ever had a problem with concurrency if a lot of requests come in and then you're going to post our issues? Yes, of course. So that's when you have to adjust for 3% higher, right? So you kind of wander that. So even though it's serverless, right? You still have to kind of deal with the start problem with any language. And I would want to do something around kind of auto kind of reporting. That would be kind of neat. Then you don't want me to deal with that, right? You can use kind of the historical information to figure out when, how often. That would be really fun. And I'm happy to take pull requests too. Okay, well, I'll be around here for any kind of questions one-on-one you guys want. I'm just basically hanging out until tomorrow. Okay, cheers guys. Thanks. Thanks for coming.
This is the presentation giving us any monitoring with Israel, but any other area. Israel, I think it has such problem that it doesn't talk about some other things. Keep reading everything shorter. So feel free to ask me. We'd love to continue that in the future probably, but then yesterday. More questions? No, so we just want to get people. So let's look it up and then we'll see like who will get on. So, did anybody not get the video? Can you open the slide? Because I'm sure you can show you. This slide is at least all the 5 remaining many books and videos you can get. Videos are of course like online, ebooks, most of them, but I have one created for the Google for right here. So we can take it with it. For the rest of the contact and whatever it is, to get the code for the 100% discount. So it's somewhere close to good.
Full screen and then go to end.
So okay, I'll allow HR to do a lot of agreement, plus whoever came late actually is looking for folks and doing also.
The winner is 5408443.